The next thing we're going to talk about is, now that we know how to find the mean and the median, what does it tell us about a distribution? The one thing that it's going to be able to tell us is going to be the shape of the distribution. Shape generally means, where does most of the data lie? It can lie to the left of the distribution, which means it lies in the lower values. It can lie to the right of the distribution, which means it lies in the higher values, or it can be evenly dispersed throughout the distribution, which means you have low, high, but most of your values are falling in the middle. So let's look at a couple of shapes. The first shape we'll talk about is what we call symmetric. And this occurs when the mean is equal to the median. The most common symmetric distribution is going to be what we call the normal distribution. And it is the distribution which gives you this bell curve right here. So this is the normal curve, or the bell curve. Another type of symmetric distribution is the uniform distribution, which is a rectangle. It basically is the probability of getting all of the same numbers. Or, for instance, when you roll a die, what's the probability you roll a 1, a 2, a 3, a 4, a 5, or a 6? Well, their probability is 1/6 for each one of those numbers. Since they have the exact same probability of occurring, we call it a uniform distribution. Now, the word symmetric here means that you have tails. And we're going to look at these curves that we're going to start drawing now. You're going to draw these curves of your distributions as best you can. And like for this one, it looks something like that. When you have these curves, what you're looking at, you're going to look at the tails of the curve. And notice here you have tails on both sides. When you get tails on both sides and a peak in the middle, you get what's known as a symmetric distribution. And in that distribution, the mean will be equal to or approximately equal to the median. The next type of distributions we're talking about is what we call skew. If a distribution is not symmetric, it's said to be skewed. The skew always talks about the mean. We have two types of skew. The first skew is what's called a left skew distribution, or also known as a negative skew. What that means is that the tail on the left of the graph is longer than the right side. And if you draw a curve over this graph, you're going to see that your tail is longer here. When the tail is longer on the left, the mean will be less than the median. And we always compare the mean to the median. The mean comes first and then it's the median. So this means that you're typically getting a lot more large values than small values. So this should say there are more large values than small values. You can think of this as being an easy test. Let's say the grades on the test are, here's a 60, here's a 70, here's an 80, here's a 90, here's a 100 out here. Well, you can see more people are scoring better than the passing score of a 70 out here, which means that this is basically an easy test where you have a lot of large values but very few low values. And here's what happens with the mean. The mean is heavily influenced by extreme values, which means that if we all score hundreds on a test and one person scores a 0, what happens to the mean? It drops because of that one person. It's because what the mean wants to do is try to balance out the data. So when we talk about skew, left skew, we're actually talking about what's happening to the mean. The mean is being skewed to the left because of the lower values, a small amount of lower values. In a right skew distribution, or a positive skew, the mean now sits on the right-hand side of the curve. So again, when you draw your curve, your tail's on the right again. And this right here is going to be like a hard test. Because again, if you place values, you have 60, 70, 80, 90, 100. You notice that more people are scoring lower than the passing value here. And here the mean will always be greater than the median. So let's say you want me to curve a test because most people have failed, but a few people have done exceptionally well. What do they do to the mean? Do they bring it up or do they bring it down? Well, they'll bring it up because their score is higher and it's going to pull the mean in this direction. This means that there are more there should be small values, then large values. So again, remember, Skew talks about the direction that the mean is going. And in general, here's the best way to remember it. The mean always lies in the tails. So it always sits out here in the tails, in the direction of the skew. This means the mean will always fall in your tail. So it's always in the direction of the skew. So if you're left skewed, it's sitting in the left tail. If you're right skewed, it's sitting in the right tail. And it does that because the way we find the mean is through adding up all the values in the data set, which means that small values are going to contribute to it just as much as large values are going to contribute to it. And because of that, it's heavily influenced or is largely affected by extreme values called outliers. An outlier is just an extreme value for right now. On the other hand, the median doesn't care about all the other values. It just wants to sit into the middle of the data set. It's a positional measure. So the median uses a position rather than the actual data to calculate its value. Therefore, it doesn't care if you're far away or close to it. It just needs to sit in the middle. So what does this all mean? Well, when we calculate the mean and the median, what we're really doing is we're using it to describe the data set. When we talk about the data set, we're going to talk about a measure of central tendency again, which again, remember, is the mean or the shape of the distribution will tell you which particular central tendency measure to talk about. If the distribution has outliers or very extreme values, a representative central measure is going to be the median. And that's because the median is what we call resistant, which means it's not affected by those values. And it's going to be the typical value. The problem with the median, though, it's only one value. It only takes into account the center value or the middle value. If the distribution is symmetric, it's representative of the entire distribution. We talk about the mean. The mean is non-resistant, which means it's heavily affected by outliers. But the best thing about the mean is that it takes into account every value. Every value contributes to the mean, which means it gives us the most amount of information we can get from any particular value. But that's only valid if that distribution is symmetric. So remember, the distribution is skewed, you talk about the median because it's resistant, which means it's not affected by outliers. The distribution is symmetric, you talk about the mean, which is a non-resistant measure. So here's an example of how we use this. This says the Houston Rockets have two superstar players that make around $25 million each. The other players on the team vary in salary from league minimum, about $300,000, to the third highest paid player, about $14 million. The average salary for a player on this team is $12 million. The median salary is about $2 million. Players and owners are preparing for a strike. The players feel like they are being underpaid, while the owners want to portray to the public and their fans that the players are making enough. Which measure of center, mean or median, should each side argue to justify their concerns? So let's do this. Let's pick a side. So either you're a player or you're the owner. The players want to get paid more, so they want to seem like they are being underpaid. Need to seem like being underpaid. The owners don't want to pay more, so they need to see like the players are overpaid. Well, which measure of center or typical are we going to use for each side? For the players, do I want to argue the average, which is the average, which we call BU here, because we know every player on the team is 12 million, or the median, which is only 2 million? First question is, why are there such a big discrepancy between the mean and the median? Well, because the mean is 12 million and the median is 2 million. What do we know about the shape of the distribution? Here, our mean is greater than the median. And when the mean is greater than the median, we know the distribution is, well, again, the mean lies in the direction of the skew. Here it's greater than, so it has to be right skewed. Well, what does right skewed mean? Right skewed means we have a lot of players. In this particular case, we have a lot of players getting paid a lot of little money, and then we have a few players getting paid a lot of high money. So these are your superstars. These are your average players. So is it false of anybody to say, or any reporter or any owner to say, that we pay our players on average 12 million? No. But is that going to be a typical value for a person on this team? No. So if the players want to make more money or need to get more money, they're going to argue the median. They're going to say that the median is only $2 million and we need more. The owners, on the other hand, are saying, hey, we pay an average of $12 million. But they're paying that 12 million, that average, that high amount, to mainly two superstar players. So they're going to argue that the mean is equal to $12 million. Well, in this case, which value is more representative of the entire population? And the answer here is going to be the median. Median is the more typical value for the entire population. And so here we can see that when we compare the mean and the median and we look at this shape, the shape of this distribution is highly skewed, right skewed, and it's being pulled out there by these $25 million superstars. So because the distribution is skewed, we always talk about the median as the more representative value of the entire population.